All right, third video, let's talk about extraneous roots. So that means that when we verify, left-hand side is going to look a little bit different than right-hand side. But first what we need to do is state the restrictions. So there's no restrictions on this end, but with this end right here, we say that 5 minus n must be greater than or equal to 0. I'm going to subtract 5 from both sides. Negative n is greater than or equal to negative 5. And I'm going to multiply through by a negative 1. So I'm going to flip the direction of the inequality, and I get n is less than 5. So n must be less than 5 in order for this to work. And that makes sense. 5 minus, say something like 4. That produces something positive. Or if I say 5 minus negative 1, that means 5 plus 1, which is the square root of 6. So that makes it so that the restrictions, it makes it so the radicand is still positive. So in this case right here, we still want to isolate the radicand, the radical. So I'm going to subtract n from both sides. So that becomes minus 5 minus n equals negative 7 minus n. Whew! That's a lot of negativity. So I'm just going to go in and multiply each term by negative 1. So that means that this becomes positive 5 minus n equals negative 7 times negative 1 is positive 7. And then this becomes plus n. I'm just going to change this side to a format that we like a little bit better. It'll help us in expanding. So then that's the square root of 5 minus n equals n plus 7. What we're going to do is we are going to square both of these. Now in the case of this side, it simply results in 5 minus n, whereas this side becomes is a perfect square binomial. So that becomes a trinomial when we expand it. It will become n squared plus 14n plus 49. That looks like 4a. Yeah, 49. So now what I'm going to do is I'm going to set one side equal to 0, and then we're going to solve for n. So I'm going to add n to both sides. So that becomes n squared plus 15n, and I'm going to subtract 5 from both sides. So 49 minus 5 is going to be plus 44. Now to solve this quadratic, I need to factor, or I can factor, it's the easiest, two numbers that multiply out to 44 and add up to 15. That's going to be n minus 11, sorry, n plus 11, and n plus 4, because 11 times 4 is 44, 11 plus 4 is 15. So that means that our solution to n is negative 11 and negative 4. If we look at this right here, this will satisfy the restrictions with the radicals. Negative 11 is less than 5, which is great, and negative 4 is also less than 5. It's important to make note of those. But let's solve, or let's substitute in here. So when n equals negative 11, we have negative 11 minus the square root of negative 5 minus negative 11. And the right-hand side is simply going to be negative 7. So negative 11 minus the square root of 5 plus 11, because negative times a negative is a positive. So that's 16. Negative 11 minus 4 is negative 15. Interesting. So left-hand side does not equal right-hand side. So we cannot say that n equals negative 11 is a solution. It produces an extraneous solution. What happens when n equals negative 4? So we say n here, so negative 4 minus the square root of 5 minus negative 4, and the right-hand side is still negative 7. So this is negative 4 minus the square root of 9. Negative 4 minus 3 is negative 7. Left-hand side equals right-hand side. this does not result in an extraneous solution. So in my final answer, I'm going to state that n equals -4. What's something that's very important is that we visibly reject. That sounds a little harsh, but we visibly reject that -11 by putting an x through it. That means that we've tried it out and we know that it doesn't work. All right, what about this last one? That line kind of masked an important piece. So this one, I can just square both sides right off the hop because they are both radicals. So I say x minus 1 equals 2x plus 3, and I'm just going to isolate the x variable, subtract x from both sides. -1 equals x plus 3, and subtract 3 from both sides. So so then x is -4. Something that I didn't do right off the hop that I need to do is I need to state my restrictions. So I must say that x minus 1 must be greater than or equal to 0. X has to be greater than or equal to 1. And on the other side, 2x plus 3 must also be greater than or equal to 0. Subtract 3 from both sides. 2x must be greater than or equal to -3. X must be greater than or equal to -3/2. So in order for both of these restrictions to be satisfied, we have to go with this one. X must be greater than or equal to -1. Why? Because x being greater than or equal to -3 is less than this one. So this restriction wins out. So let's just compare. X must be greater than or equal to +1. X equals -4. So even though we have one solution, let's just see what happens when we verify. Left-hand side, right-hand side. So the square root of -4 minus 1, I see a problem right away. And the square root of 2 times -4 plus 3. And in fact, this equation fits neither of these restrictions. So it's so little. It doesn't fit either one of the restrictions. So the square root of -5. And then this one would be the square root of -8 plus 3, which is also the -5. Okay, square root of -5. Now, this right here, the left-hand side does indeed equal the right-hand side, but they're both impossible values in a real number system. Now, when you get to university and you study imaginary numbers, that's something different. But right now, we can say that there are no real solutions. Though there are imaginary solutions, which sounds a little bit mind-boggling, but remember the imaginary number system is always based on I, which is the square root of -1.